differentiability. So what is differentiability of a single valued functions? Okay, so let fx be a real valued function defined on closed interval ab, then fx is said to be differentiable in C belongs to AB such that limit s tends to 0 f of c plus h minus fc upon h exists. Okay, it means a function fx is differentiable at point c, where c lies between a and b in open interval ab, such that this limit exists. Okay, then this function is differentiable. In other words, limit x tends to c f x minus f c upon x minus c exists. So now the limit exists, it means left hand derivative and right hand derivative equal, and both limit exists. It means what is left hand derivative? So let fx is a function of x, then left hand derivative of fx at x is equal to c is denoted by f dash c minus 0. Okay, and f dash c minus 0 is equal to limit s tends to 0 f c minus h minus fc upon minus h. And similarly, right hand derivative. So in the right hand side of point C, it means what is right hand derivative? So right hand derivative of fx at c is denoted by f dash c plus 0 and is defined by f dash c plus 0 is equal to limit s tends to 0 f c plus h minus fc upon h. Okay, where h is positive real number. So if left hand derivative and right hand derivative both exist and equal, so a function fx is differentiable at x is equal to c if left hand derivative means f dash c minus 0 equal to f dash c plus 0, provided both limit exists. Okay, provided both exists. Okay, so this is the meaning of differentiability. So now I am going to explain some examples on differentiable function. Okay, so first example fx is equal to x square. So this is parabola. Okay, so I want to check this is differentiable or not at point 0 and 1. Okay, so first we will solve differentiability at x is equal to 0. Okay, differentiability at x is equal to 0. So how we will check? So first we will explain left hand derivative is equal to f dash c plus 0. C is nothing but 0. So 0 minus 0 is equal to limit s tends to 0 f 0 minus h minus f0 upon minus h. Putting in formula means f dash c minus 0 is equal to limit s tends to 0 f c minus h minus fc upon minus h. So here at c is equal to 0. Okay, So this is equal to h tends to 0 f half minus h minus f0 upon minus h. Okay, so this equal to limit h tends to 0. What is f of minus h? So fx is equal to here x square. So f of minus h is equal to minus h square is equal to h square. So here this is h square minus 0 upon minus h. So this is equal to h cancel. So limit h tends to 0 minus h. On taking limit, so this is equal to 0. And similarly, right hand derivative. So what is right hand derivative? So f dash c plus 0. So this is 0 minus 0 because c is equal to 0. So this is equal to limit h tends to 0 f 0. This is c plus f dash c plus 0. So 0 plus h minus f 0 upon h. By the definition of right hand derivative, so limit h tends to 0, f0 plus h and fh, so f half h is equal to h square minus 0 upon h. So this is h tends to 0, h, because h is cancelled. On taking limit, this is equal to 0. So since left hand derivative and right hand derivative both are equal and finite, okay, therefore given function fx is differentiable at x is equal to 0. Similarly, you can calculate at x is equal to 1. So here at x is equal to 1, here f dash 1 minus 0. So 1 minus h minus f0 upon, sorry, f of 1 minus h minus f1 upon minus h. Okay, so in place of 0, we will put 1. Okay, at x is equal to 1, left hand derivative is equal to f dash 1 minus 0. By definition, limit s tends to 0. What is the definition? F dash c minus 0 is equal to limit s tends to 0 f c minus h minus fc upon minus h. Okay, so this is equal to limit s tends to 0 f 1 minus h minus f1 upon minus h. Okay, so since f of x is equal to x square, so this equal to f of 1 minus h is equal to 1 minus h square, and f1, so f1 is equal to 1 upon minus h. Okay, here minus, so this is equal to limit h tends to 0 1 plus h square minus 2h minus 1 upon minus h. 1 cancel. So by taking common h in numerator, so this is equal to h minus 2 upon minus h. h is cancel. On taking limit, so we get minus minus plus, so this is equal to 2. Similarly, right hand derivative. So what is right hand derivative? Right hand derivative is equal to f dash 1 plus 0. Okay, so this is the notation. So by definition of right hand derivative, f of 1 plus h minus f1 upon h. Okay, again, since fx is equal to x square, since fx is equal to x square, so this is equal to limit h tends to 0 1 plus h whole square minus f1. f1 is equal to 1 upon h. Again, limit h tends to 0 1 plus 2h plus h square minus 1 upon h. So this equal to limit h tends to 0. On taking common h numerator, so 2 plus h upon h. On taking limit, so this is equal to 2. So since left hand derivative is equal to 2, right hand derivative is equal to 2, both are equal, left hand derivative equal to right hand derivative. Both are equal and finite. Therefore, given function is differentiable at x is equal to 1. Now, I want to check the given function f(x) is equal to mod x. This is mod x. So this is differentiable at x is equal to 0 or not. Okay, so this is the graph of f(x) is equal to mod x. Okay, so first we will check, means at x is equal to 0. So here f(x) is equal to mod x. Okay, so left hand derivative equal to f dash 0 minus 0, because here c is equal to 0 means point is 0. So this equal to limit h tends to 0 f 0 minus h minus f0 upon minus h. Okay, so this equal to limit h tends to 0. F of 0 minus h is equal to f of minus h. F of minus h is equal to mod minus h minus mod 0 upon minus h. Okay, so here mod minus h is equal to h minus 0 upon minus h. So h's cancel, so this is equal to minus 1. And right hand derivative. So what is right hand derivative? F dash 0 plus 0. So this equal to limit h tends to 0 f of 0 plus h minus f of 0 upon h. Okay, so what is f 0 plus h? Is nothing but f of h. So this equal to fh is equal to mod h. Mod h minus f0 is equal to 0 upon h. So this will equal to mod h is equal to h upon h. So this is cancel, this is equal to 1. So here left hand derivative is minus 1, right hand derivative is 1. So this is not equal. Since left hand derivative is not equal to right hand derivative, therefore function is not differentiable, okay, at origin. So it is very clear that this is our function, okay, fx is equal to mod x. So this is not differentiable. In geometrically, this is very nice definition of differentiable function, means a function is differentiable at point. So at that point, both tangents are common, okay. But at this point, if we draw tangent, so this will go this type, and here this is here this type. So both tangents are different. So this is not differentiable. It means left hand derivative and right hand derivative both are not equal. Therefore, this is not differentiable. So now, relation between continuity and differentiability. As we know, we have studied before what is continuous function. So in continuous function, left hand limit is equal to right hand limit is equal to value of function at x is equal to a. Now I am going to explain relation between continuity and differentiability. Okay, means if a function f(x) is a single valued function, so at x is equal to a, if this is continuous, then left hand limit is equal to right hand limit is equal to value of function, means f of a minus 0 is equal to f of a plus 0 is equal to fa. Okay, in this case function is continuous. But in case of differentiability, left hand derivative is equal to right hand derivative if both exist. It means f dash a minus 0 is equal to f dash a plus 0. So what is the relation between continuous function and differentiable function? So this is very important, that every differentiable function is continuous. Okay, it means if a function is differentiable, then sure this is continuous. But converse is not true always. It means if this is continuous, so may be differentiable, may not be differentiable. So this is very important result. So here, this is an example. This is a function fx is equal to x square. So this is differentiable at 0 and 1, between 0 and 1 also. Also this is continuous, because if we start this pen from here to here, so this is continuous. And also we have checked for differentiability. It means this is differentiable as well as continuous. But see, very nice example, fx is equal to mod x. So this is continuous, means if we start from here, so no any break. Okay, so this is continuous, but not differentiable at x is equal to 0. I have explained here. Okay, so what is the meaning? It means at x is equal to 0, if we draw tangent, so left hand tangent and right hand tangent, both tangents are not coincident. It means if a function is differentiable at any point, so at that point both tangents are coincident. Okay, but here one tangent goes to this side and other tangent goes to this side. Therefore, this is not differentiable. It means at corner any function which is not differentiable but continuous. Okay, so this is the main difference between continuity and differentiability. Now, this is very important remark. Okay, so if you have given only one function, okay, gx, so you will calculate left hand derivative and right hand derivative both for this function. But you have given two functions, means fx is equal to gx when x less or equal to a, and fx is equal to hx when x greater than a. So in this type of questions, in case of left hand derivative, we will calculate value of gx, means when x less than a, means in the case of less than, LESS less than. Okay, this is L, so you take left hand derivative. Okay, and hx means in the case of right hand derivative, we will take x greater than 1 a. Okay, so this is very important to calculate any question. So if you have given two function, so in case of left hand derivative, we will take this value, and in case of right hand derivative, we will take this value. Okay, so this is very important question, means test continuity and differentiability of a function fx is equal to x sine 1 upon x when x not equal to 0 and 0 when x is equal to 0. So at x is equal to 0, we will test continuity and differentiability. Okay, so first we will check continuity. So what is continuous function? So first we will obtain left hand limit, right hand limit and value of function. Okay, so left hand limit, this is equal to f 0 minus 0 is equal to limit s tends to 0 f of 0 minus h. This equal to limit s tends to 0 f of minus h. Okay, so what is fx? Fx is equal to limit s tends to 0, fx is equal to this thing. So f of minus h is equal to minus h sine 1 upon minus h. Since sine minus theta is equal to minus sine theta, so this is minus minus plus. So h tends to 0, h sine 1 upon h. Okay. Now, what is 1 upon 0? Infinity. Sine infinity. Since sine theta minus 1 less or equal to sine theta less or equal to 1. It means for what value of h? This always lies between minus 1 plus 1. Means this is finite. So 0 into finite number is equal to 0. Okay. 0 into finite number. So this is equal to 0. Okay. So this is left hand limit. Similarly, right hand limit. Right hand limit is equal to f of 0 plus 0 is equal to limit h tends to 0 f 0 plus h. This equal to limit h tends to 0 f of h. So h sine 1 upon h. So this is same as this thing. So this is equal to 0. Now, what is the value of function at s equal to 0? So this is given in the question. Okay. It means left hand limit is equal to right hand limit is equal to value of function. Okay, therefore function is continuous. Function is continuous. Now we will check differentiability. So first we will obtain left hand derivative. So left hand derivative is equal to f dash 0 minus 0. This equal to limit h tends to 0 f 0 minus h minus f 0 upon minus h. Okay. So this is equal to limit h tends to 0. F of 0 minus h means f of minus h. So minus h sine 1 upon minus h. f0 is equal to 0 given in question. So this is 0 upon minus h. Okay, so this is cancel. So this equal to sine minus theta is equal to minus sine theta. So minus sine 1 upon h. So on taking limit 1 upon 0. What is 1 upon 0? Infinity means limit h tends to 0 minus is here sine 1 upon h. So this value lying between minus 1 to plus 1. So this is a finite number, but we can't say which number is exist. It means limit does not exist. Because limit h tends to 0, sine 1 upon 0, this value lying between minus 1 and plus 1. Okay, therefore limit does not exist. Okay. Similarly, in case of right hand derivative, this equal to f dash 0 plus 0 is equal to limit h tends to 0 f 0 plus h minus f0 upon h. Okay, so this equal to limit h tends to 0 h sine 1 upon h minus 0 upon h. It is cancelled. So on taking limit, again, this is the same condition, means this limit lying between minus 1 and plus 1. So this is not exist. Okay. It means neither left hand derivative nor right hand derivative exists. Therefore function is not differentiable. Therefore function is not differentiable. Okay. So this is the procedure to solve differentiable and continuous functions. Okay.